In this video, we're going to look at the alternating series test, which you see in front of you. And the alternating series test can be applied to an alternating series. Now, how do I know from this definition here that I have an alternating series? The alternating series, this business right here, how do you know it's alternating? It's this stuff, right? When you see this deal, -1 to the k plus 1, or actually it could be -1 to the k. And the reason they don't have that specified in this definition here is because they're not telling us what values k is starting at. All right, so if I had k starting at 1, this would make this a positive. If I had k starting at 0, this would make this a negative. So, but if you're doing practical type problems, the way you're going to identify that it's an alternating is it has one of those two terms right there. Okay, so let's say we have some alternating series and we're trying to determine whether it converges. So what the alternating series test says is if it meets these two criteria, then it converges. So in the last video, if you watched that, I was doing a particular example which I had named a sub k. I'm going to rename it here b sub k, which you'll see why in a minute. And we were doing, let's see, we were doing -1 to the k plus 1 over k. All right, so what I want to do is I want to rewrite that in this form here. So what I'm asking myself now is I want to know, does this infinite sum from k equals 1 to infinity of -1 to the k plus 1 over k, does that converge or diverge? And I want to try to use the alternating series test. There might be other tests. I'm sure there are other tests that we could use on this. So what I want to do is I want to rewrite this in this form right here as my -1 factor. And again, if this was -1 to the k, you could do the same thing here, times some other sequence. All right, so I'm going to rewrite this, and I'm just going to separate out this factor that makes it alternate. And then I'm going to write times 1 over k. All right, so this 1 over k becomes a sub k. This is some other sequence. So in this case, let's write it over here. A sub k is equal to 1 over k. So what it says here is this guy, the alternating series, is going to converge provided the terms of the series are non-increasing in magnitude. All right, so when they're talking about magnitude here, they're talking about basically the absolute value of that term. When we talk about magnitude of something, we're ignoring the sign. So in the last video, we wrote out our terms. So our b sub k terms were 1, -1/2, third, -4th, a +5th, etc. So if I'm looking at the magnitude of these terms, it's 1, 1/2, a third, a fourth, a fifth. So those are non-increasing. Remember, the only difference between non-increasing and decreasing is that non-increasing could also be equal to. So for this particular example, these are actually decreasing in magnitude because I don't have two terms that are equivalent in this particular example. Okay, so that's check, right? The terms of the series are non-increasing in magnitude. That's check. Now, when it says terms of the series, you know, you guys are used to this idea of terms. If I give you a polynomial and I say, how many terms does that have? You'd say, oh, that has 3 terms. So when I'm talking about the terms of the series itself is going to be 1 minus 1/2 plus a third minus a fourth plus a fifth, etc. So the terms of the series are the 1, the -1/2, the third, the -4th is the things that we're adding up. The terms of the series are synonymous with the values of the sequence. The terms of the sequence are the terms of the series. Okay, they're kind of the same thing. All right, so that's met. We got that. Next thing we need to check and see is that the limit as k approaches infinity of a sub k equals 0. So remember that a sub k is basically our alternating series without the alternating part. It's this stuff over here. So a sub k is 1 over k. I already wrote that. We'll just use that again. So what I need to look at for my second option here, for not option, I should say criteria, my second criteria is I need to see if the limit as k approaches infinity of a sub k, which is 1 over k, does that equal 0? Well, pretty clear to see here that the terms of this guy are 1, a half, a third. That's 1, a half, a third. The denominator goes to infinity, the numerator stays 1. If the denominator is increasing without bound and the numerator is constant, then the limit is 0. So check. All right, we've met these two criteria. So what that means is that we can conclude, therefore, by, let's be a little bit lazy here, the alternating series test, that the infinite sum from k equals 1 to infinity of -1 to the k plus 1 over k converges. Use that little symbol for converges. What does it converge to? I don't know. Actually, we could try to figure it out with partial sums and do some estimating, which we did in the last video, so we have kind of an idea where it is, but the alternating series test doesn't tell us what it converges to, it just tells us that it converges. So this is a little bit of an interesting example, because if you remember, the infinite sum from k equals 1 to infinity of 1 over k is divergent. But if we make this alternating, it becomes convergent. All right, in the next video, we're going to look at another example.